Hello everyone. Today we are going to learn about K-nearest neighbor algorithm in machine learning. At the end of this session, student will be able to apply KNN on given dataset. The KNN algorithm is a simple but extremely powerful classification algorithm. The name of the algorithm originates from the underlying philosophy of KNN, that is, people having similar background or mindset tend to stay close to each other. In the same way, as a part of KNN algorithm, the unknown and unlabeled data which comes for a prediction problem is judged on the basis of training dataset elements which are similar to the unknown element. So, the class label of unknown element is assigned on the basis of the class label of the similar training dataset elements. Let us consider example given here. We have the data set of 15 students who are studying in a class. Now, each of the student has been assigned a score on a scale of 10 on two performance parameters, that is aptitude and communication. Also, a class value is assigned to each student based on the following criteria. First criteria, the student having good communication skill as well as good level of aptitude have been classified as a leader. Then the second criteria is students having good communication skill but not so good level of aptitude have been classified as a speaker, while the students having not so good communication skill but a good level of aptitude have been classified as an intel. So, as we already know, while building a classification model, a part of the label input data is written as test data. The remaining portion of the input data is used to train the model. Hence, it is known as a training data. The motivation to retain a part of the data as a test data is to evaluate the performance of the model. As we have seen, the performance of the classification model is measured by number of correct classification made by the model when applied to an unknown data set. So, however, it is not possible during model testing to know the actual label value of an unknown data. So, therefore, the data which is to be tested, that is test data, which is part of the label input data, it is used for this purpose. If the class value predicted for most of the test data elements, it matches with the actual class value that they have, then we can say that the classification model has a good accuracy. In the context of the student data set, to keep the things simple, we will assume one data element of the input data set as the test data. Now, this is our given data set. Now, here in this context of the student data set, we will assume one of the record as a test data. So, that record we will consider as a test data, that is the last record, and the remaining 14 records are considered as a training data. So, the last row with name Shirish and aptitude marks 5, communication 4.5, we will consider it as a test data. So, the training data points of the student data set aptitude considering only the features aptitude and communication can be represented as a dots in a two-dimensional feature space, which is given as. So, in this two-dimensional feature space, we can see that the data points which are close to each other are clustered together. For example, speaker, leader and intel, they are clustered together. So, to find out the closest or nearest neighbor of the test data point, Euclidean distance of the different dots need to be calculated from the test data point. Then, the class value of the closest neighbor helps in assigning the class value of the test data element. Now, can you tell me how many similar elements we should consider while applying this K-nearest neighbor algorithm to the given data set? So, the answer lies in the value of k, which is a user defined parameter given as an input to the algorithm. So, in KNN algorithm, the value of k indicates the number of neighbors that need to be considered. For example, if we have value of k equal to 3, then only 3 nearest neighbor or 3 training data elements closest to the test data element are considered. Now let us consider the data set again. Now here the first 14 rows are training data, while the last row is the test data. Now here now we want to find out to which class the Shirish will belong. So this can be done by calculating the Euclidean distance. The formula for Euclidean distance is square root of x2 minus x1 square plus y2 minus y1 square. Now in this case we have x2 comma y2 as 5 comma 4.5. So for given data set we need to predict the class. We have Euclidean distance formula. Then in this case we need to calculate the distance of each data point, that means distance of Ajay from Shirish, Vijay from Shirish, Shri from Shirish, like that all data points we need to calculate. So here the distance for data point Ajay and Shirish is calculated as square root of 5 minus 2 square plus 4.5 minus 5 square, which is 3.041. Again using the same Euclidean distance formula, the distance between Shirish and Vijay is calculated like square of 5 minus 2 plus square of 4.5 minus 6 equal to 3.354. So similarly the distance for all the data points is calculated and the value of that data point is given over here. Now let us consider the value of k equal to 1. K equal to 1 means here we will consider only the value like which is minimum for the calculated data point. So that minimum value, as we can see for the name Bobby and the distance calculated is 1.118. When if we have k equal to 1 means we need to consider only one cluster which is closest to the Shirish, that is for which we wish to find out the distance. In that case, if k equal to 1, then the class will be allocated to Shirish will be Intel. Okay. Now suppose value of k equal to 2, then along with the value of k equal to 1 with name Bobby and class Intel, there is one more class which is identified as a leader with name Rohan. So for this again, if value of k equal to 2, then there will be a dilemma that which class we can assign to the Shirish. So minimum value of k is there will be the confusion if which class we have to apply for the new data set, test data set. So now consider k equal to 3. Now when we consider k equal to 3, then we have one more cluster that is Om with class Intel. So for value of k equal to 1 we have Intel, for value of k equal to 2 we have Intel and leader, while for value of k equal to 3 we have Intel, leader, again Intel. So here with the value of k equal to 3, the class label for Om and Bobby are Intel, while for Rohan it is leader. So by considering the majority, Shirish is assigned a class label as an Intel. So based on the Euclidean distance, we need to calculate the nearest neighbor of the given test data set. So here the nearest neighbor are Rohan, Bobby and Om. Based on the majority of their class, the class is predicted as an Intel. So the Shirish will be assigned to the class Intel. Now the strength of the KNN algorithm. It is extremely simple algorithm and it is easy to understand. It is very effective in certain situations, for example recommender system design. Now the weakness of the KNN algorithm. It does not learn anything in the real sense. The classification is done completely on the basis of training data. So it has a heavy reliance on the training data. If the training data does not represent the problem domain comprehensively, then the algorithm fails to make effective classification. So the classification process is very slow. Also, a large amount of computational space is required to load the training data for classification. Application of KNN. KNN is widely adopted for recommender system. As we know, recommender system recommend user different items which are similar to particular item that the user seems to like. So the liking pattern may be revealed from the past purchase or browsing history, and the similar items are identified using the KNN algorithm. Another application is searching documents or content similar to a given document or content. So this is all about the K nearest neighbor algorithm. This is the reference. Thank you.